So in this video we're going to consider a marvelous tool called the product rule. And I've mentioned on a number of occasions that we don't have a product rule yet. That if we have two functions being multiplied to one another and we need to take the derivative, we're kind of stuck. So this is fairly exciting that we now have a way to take those derivatives. So here's the product rule. Okay. It says that if you want to take the derivative of one function f of x times another function g of x, so if you've got two functions multiplied together, the way that we do it is this. You take the derivative of the first function and multiply it by the second function left alone. Right? So notice this is f prime of x, and then this is g of x. Then we do plus the original function, I'm sorry, not the original, but the first function f of x, times the derivative of the second one, so g prime of x. So you can think about it as the functions take turns being the derivative. In the first one, it's the first derivative times the second function plus the first function times the second function's derivative. And that's all we have to do to take the product rule. Like sometimes you're going to need to simplify what's here, but the product rule at its core is quite simple. So the first example that I have is I would ask us, hey, can we find the derivative of 6 cosine x minus 3x squared? And think about why that doesn't require the product rule. And so sort of pause the video for a second and think whether or not you think that this problem would require a product rule in any sense. Right? And it really doesn't. One is that there's a subtraction in between. The only place where somebody might think that the product rule is necessary is right here where it says 6 cosine x. You might think, hey, there are two functions there. There's 6 and there's cosine x. But remember, we actually have the constant multiple rule. The constant multiple rule says that if you have a constant times something, if you have 6 times cosine x, we just ignore the 6 and then do the derivative of the cosine x, which is negative sine x. Right? The same with the 3. We have minus 3 times the derivative of x squared, which is 2x, and then we just go back and we simplify. So the point that I wanted to make here is that when you have two things multiplied together, we don't always need to do the product rule. We only need it when we actually have two variable functions that are being multiplied by one another. And I have a few examples of that, so we'll go on and see those. So here's that first example. So if g of x equals 4x cubed times cosine x, I want to find g prime of x. So the two functions here are basically 4x cubed and cosine x. So I'm now going to go through and take those derivatives. And actually, if I want to use the same color coding I did before, we'll make the first function blue and the second function red. So if we want g prime of x, we'll have the derivative of the first thing is 12x squared. Then we'll leave the second function alone, cosine x, plus, this time I'll leave the first function alone, 4x cubed, and I'll multiply by the derivative of the second function, negative sine x. Now I mentioned that from here, lots of times we want to kind of, make things a little bit prettier. So, I'll 12x squared cosine x, there's not a whole lot I can do about that. Over here I can at least pull the negative to the front. And then something I want us to be in the practice of doing, if there is anything that can be factored out of this expression, I think it's worth factoring out. It makes for expressions that look a little bit prettier. So I could pull out the 4x squared. I could factor out the 4x squared. That leaves me with 3 cosine x minus x sine x. And this is the answer that I'm going to prefer. There's nothing wrong with this one up here, but I really feel like this one that we have down here at the bottom is better. And there are a number of reasons for that. I'm not going to go into many of them right now, but the least of which is if you need to find horizontal tangents, setting this equal to 0 is much nicer since this is already factored. So here's another example for us. The derivative of 10 root x times sine x minus 3x to the 8th. And the point of this example is just to show you, like, hey, we need to use a product rule on this because this is something times something else, but then we just have minus this other thing. I'm just going to do the product rule on this part and then the power rule on this part. So I would like you guys to pause the video and try working through this one on your own. So please do that now and then we'll check answer. So again, we're going to need to do the derivative of the 10 root x and the sine x sort of as separate derivative pieces of the product rule, so we'll go through and do that now. The derivative of 10 root x is going to be 10 times 1 over 2 root x. Remember that root x is kind of a memorized derivative. Then we leave the sine x alone. And we have plus, I'll leave the 10 root x alone, and multiply by the derivative of sine x, which is cosine x. Then we just have minus 24x to the 7th. So it's totally reasonable to have a product rule for one part of it, and then some other rule for the other part of it. If I were to go through and simplify this, I would have 5 sine x over root x, plus 10 root x cosine x, minus 24x to the 7th. In this case, there's really nothing that can actually be factored out of this whole thing, so that's our answer. Nothing I can really do with that. The last question I'm asking is to find the equation of the line tangent to f of x equals x sine x at x equals pi over 2. This is a problem that I'd also like you guys to try and do on your own as much as you can. The one thing I'll remind you of is that finding a tangent line requires two things. And so you should already be thinking about what those things are, and I'm going to sort of set us up for it. We're going to need to find a point, and we will also need to find a slope. So think about how you're going to do that. So we remember that finding a point just means evaluating my original function for our x value. So f of pi over 2 is pi over 2 times the sine of pi over 2. And if we simplify that, f of pi over 2 basically gives us pi over 2. So that means my point of tangency is pi over 2 comma pi over 2. Now to find the slope, I'm going to need the derivative. Right? So I'm going to need to find f prime of x. And this is the part that I definitely think you guys need to have done on your own. Like, we need to practice the product rule. So the derivative of x is 1, and we leave our sine x alone. Then plus, we leave our x alone, and the derivative of sine x is cosine x. Great, so my derivative, my f prime of x, is sine x plus x cosine x. Now to find the slope, remember I need to evaluate this thing at pi over 2. So I'll have the sine of pi over 2 plus pi over 2 times the cosine of pi over 2. Well, the sine of pi over 2 is 1, and the cosine of pi over 2 is 0, so that's 0. So my slope ends up just being 1. So finally, I actually want the equation of the tangent line, so I'll use point-slope form. Y minus pi over 2 equals a slope of 1 times x minus pi over 2. And it's actually kind of interesting. If you simplify that, you end up just getting y equals x, which is a really nice, pretty answer. So the overall purpose of this video was to show you the product rule, sort of remind you of, or rather show you how that works. So make sure that you got that out of this. We looked at a couple different examples, but do keep the product rule in mind. It's incredibly important. We're going to be using it lots.